This part file has several parameters that are named. We've taken standard parameters and given them specific names. If you plan to work with iParts, iFeatures, or iMates, they become especially useful, as iParts, iAssemblies, and iFeatures will automatically seek out parameters that have been given specific names and automatically include them in the table that you'll see drives these components. Switching to the Manage tab, I'll select Create iPart. When the iPart dialog opens, you'll see that it has a member name, a part number, and those named parameters that were listed. With a right click, we'll insert a new row. For this new row, we'll keep the member number, but we want to change out the part number. We'll edit the first part number and just simplify it down to nema motor 43. For the second one, we'll use nema motor 34. We'll update the sizes for the 34 frame, and this will give us a second part based on the original geometry. In the browser, we now have a different look for the iPart. You'll see there's a table added to the icon, and there's a table added to the browser. By double-clicking between the two family members, we can see that the motor will resize. To edit the table, just simply double-click on the table. One element you will want to include in working with your iParts is the concept of a key. When you insert an iPart into an assembly, you do not want to have to go through selecting various size options. By including a key value, it will simplify the insertion process. I'll select the part number column, right-click, and tell it that it is key 1. While we're in the motor, I'd like to add iMates. iMates are half of an assembly constraint. The first one I'll place is going to be an insert constraint at the root of the boss, centering the shaft. I'll have it a 0 offset and click OK. This will generate an iMates folder in the browser and have the insert listed. I'll rename this shaft. Then I'll start another iMate, this time a mate, and I'll use the center line for this bolt hole. Again, no offset, click OK, and I'll rename this screw. Now, rather than having to pick those separately in the context of an assembly, I'll combine them into a composite iMate by using a right-click and selecting Create Composite, which I'll rename Motor. Now I can save my file and have it ready for use by others. An iFeature is a series of features that are gathered together for reuse in other parts. Like an iPart, it's table-driven and can have variable sizes. Entering the iFeature author table, you'll see a listing of the parameters that were named and their values when the iFeature was created. I'll right-click and insert a new row and put in the new values for this version. Again, it could be difficult to choose the right size based strictly on the numbers, so I'll go to the Other tab and click to add a value. I'll create a motor size value and make sure that it is listed as a key. Then, put in the motor frame size that is associated with these values. Once I click OK, it will update the iFeature and give me multiple values to choose from. I'll save the update to the iFeature, then I can close it. I'll then open up the plate that the motor will mount to. The motor mount has 4 holes for locating the plate, but it doesn't have a way to mount the motor, so we'll leverage using the iFeature. To access the tools, I'll need another panel in the ribbon. Using the pull down at the end of the ribbon, I'll turn on the Insert panel, where I can select Insert iFeature. I'll look at the root of my workspace and find the iFeature that we just edited. Clicking Open, and then selecting a face to put it on. With it selected, we can click and drag its location. Clicking Next, we can choose which motor size we want to use initially. And then Next again, I'll tell it to activate the sketch. The reason we'll do this is to use the sketch to locate it in the component. We'll use a horizontal constraint between the center point of the eye feature and the midpoint of the plate on the left, and then a vertical constraint between the center and the midpoint of the edge on the bottom. This will help center the motor. Clicking Finish Sketch, it will update the location of the motor mount. On the Manage tab, I'll start the iMate tool again and recreate the steps that we used before with the motor by creating an insert constraint named Shaft, and it's important that you keep the naming the same, including capitalization, and a mate to the axis called Screw, creating a composite named Motor. So everything we've done has been local to this component. We'll make sure we save our work, and then go to an assembly NEMA mounted motor. Make sure we update it. This will update the motor mount component with the holes. And now we can place a NEMA motor in the assembly. Now we used a NEMA 34 when we inserted the holes. We'll make sure we import the motor as a NEMA 34. Inserting an instance of the motor, if we click on the motor, we can see the iMate. I'll click on the iMate, holding the Alt key. As I drag it to the other iMate, it will select it and snap in place. Clicking on the motor, we see the motor doesn't rotate, so we know that both constraints were connected. Returning to the motor mount component, I want to make a modification that will allow us to have a motor guard on this assembly. I only want this change to affect the second version of the component, so I'll activate that component. In the Author panel of the Manage tab, I'll change from Edit Factory Scope to Edit Member Scope. This will allow any new features that I add to the component to only affect this particular member. So I'll start a new sketch. I'll just draw a line. This line will be used to locate holes. I'll make it 2.5 inches high, 3.5 inches from the center of the motor, and constrained vertically based on the center of the line and the hole. I'll then add 2 holes to the endpoint of the line. They will be for 1/4 screws that will go all the way through. So if you activate the first member, it will not only change the geometry size of the part, but the holes will disappear as well. We'll save this update and go back to the assembly. In the assembly, we need to make sure we're up to date. We'll go to the Manage tab and create an iAssembly out of our current assembly. I'll tell it that I'd like to be able to replace the NEMA motor mount, adding that column. Let's insert another row and be able to swap out for the second version of that motor mount. This will create a table, and as you can see, we can change out which version of the mount is present. In the Author panel, we can see that Edit Member Scope is still active from when we modified the mounting bracket. With it active, I'll go to the Assemble tab and place an instance of the NEMA motor guard. Placing that in the assembly, I'll just use a joint tool, select where I'd like it located, set my alignment, and click OK. Now with that in place, let's take a look at our table for the iAssembly. Now we have a NEMA motor guard listed under Components, and we see that the joint and the guard are excluded from the first version, but included in the second. So now, if we go back to the first version of the assembly, it updates showing no holes for the guard and no guard. You can take this process and expand it for changing out motors or exchanging any number of features or components in your iAssembly.